A quantity of 10 grams of a mixture of C2H6 and C5H10 occupy 4480 ml at 1 atm 273 Kelvin. So there is a gaseous mixture C2H6 and C5H10, and this gaseous mixture has total pressure 1 atm, total volume 4480 ml, and temperature 273 Kelvin. Now we have to calculate percentage of C2H6 by mass. Percentage of C2H6 by mass. For example, C2H6 mass we are taking X grams, C5H10 mass we are taking Y grams. Therefore, the first equation is X plus Y is equal to 10. First equation. Now percentage of C2H6 by mass means X by X plus Y. Mass of C2H6 upon mass of C2H6 plus mass of C5H10 into 100. So this one we have to calculate, and this one they have give. We are assuming X plus Y is equal to 10. And according to PV is equal to nRT equation, so PV is equal to number of moles of C2H6 plus number of moles of C5H10, total moles of gas into R into T. What is the pressure value? 1 atm. What is the volume? 4480 by 1000 converted into liters equal to number of moles of C2H6. So weight ఎంత అనుకున్నాం మనం? X grams అనుకున్నాం. Therefore X by, and the molecular weight is 30 plus weight ఎంత అనుకున్నాం? Y, molecular weight ఎంత? 12 5 60 plus 10 70, 0.0821 into 273. Therefore X by 30 plus Y by 70 into this quantity is equal to 22.4 equal to 4.480. So this is the second equation. This is the second equation. And it is the first equation. On solving these two, we get X value and Y value. On solving these two, we get X value and Y value. Finally, we get corresponding X by X plus Y into 100. And the value is 30%. The answer is 30%. This question can be solved in another method. So the method is, we know that the total gas occupy 4480 ml. That means number of moles of mixture equal to weight of mixture upon average molecular weight of mixture. It is a number of moles of mixture, weight of mixture by molecular weight of mixture equal to volume of mixture upon 22.4 liters. So weight is 10 grams. Weight is 10 grams. Molecular weight of mixture we don't know, equal to volume of mixture 4.48 liters upon 22.4. 22.4. From this we calculated the molecular weight of mixture, and this molecular weight of mixture is 50. Molecular weight of mixture is 50. Now if you try to remember this one, suppose C2H6 A percentage and C5H10 B percentage by mass. It is a percentage by mass. Then the formula is 100 by molecular weight of mixture equal to A by molecular weight of C2H6 plus B by molecular weight of C5H10. So 100 by molecular weight of mixture is 50, percentage of C2H6A molecular weight 30, percentage of C5H10 B percentage, this can be written as 100 minus A because total percentage is 100. So 1% we have taken A, another percentage 100 minus A upon molecular weight of C5H10 70. So from this we calculate the corresponding percentage of C2H6 is equal to A is equal to 30%. Okay, so there are two equations important. One is percentage by mass and moles percentage or mole fraction. Mole fraction. So we use most of the time mole fraction. Average molecular weight equal to mole fraction, for example x1 into molecular weight m1 plus mole fraction x2 into molecular weight m2. Suppose if number of moles is given, we can use this one, fraction of m1 into m1 molecular weight plus fraction of m2 into m2 molecular weight, that is the average molecular weight. And this is percentage by mass. Percentage by mass. It is percentage by moles. It is percentage by mass. Therefore, 100 by average molecular weight equal to A by molecular weight of M1 plus 100 minus A by molecular weight of M2. So A is percentage of M1, 100 minus A is percentage of M2. So this formula we can use percentage by mass. This formula we can use percentage by moles. A solution was prepared by dissolving 7.45 grams of KCl in 200 grams of water in a calorimeter with a water equivalent of 25 grams. So it is a bomb calorimeter. Now it has 25 grams of water. So this is water. And it is 25 grams. 25 grams of water. And in the question it is also mentioned 7.45 grams KCl dissolved in 200 grams of water. So it is also water. It is a solvent for dissolving KCl. So 7.45 grams of KCl dissolved in 200 grams of water. 200 grams of water. The temperature of the water reduced from 28 to 25. So temperature of the water 28 degrees Celsius to 25. That means we can say endothermic reaction. Then value of delta H in kg per mole for dissolving KCl. సో మనం ఎప్పుడైతే కేసీఎల్ని వాటర్లో డిజాల్వ్ చేసామో ఏదైతే మనకి ఎండోథెర్మిక్ ప్రాసెస్ అనుకున్నామో ఆ ఎండోథెర్మిక్ ప్రాసెస్కి డెల్టా హెచ్ వాల్యూ ఎంత. స్పెసిఫిక్ హీట్ కెపాసిటీ ఆఫ్ వాటర్ ఫర్ దిస్ వాటర్ స్పెసిఫిక్ హీట్ కెపాసిటీ 4.2 joule per Kelvin gram. So we have to calculate delta H. We know that heat is equal to heat evolved by KCl dissolution Heat evolved means heat absorbed. You can say here absorbed because it is endothermic reaction. Or you can say simply involved by KCl dissolution is also equal to heat involved by water. Since it is an endothermic reaction, so you can say simply heat evolved by water. సో ఇక్కడ ఏమవుతుంది, వాటర్ అనేది హీట్ని రిలీజ్ చేస్తుంది. ఓకే, కేసీఎల్ అనేది డిజాల్వ్ అవడం కోసం హీట్ని తీసుకుంటుంది. దట్స్ వై ఇట్ ఈస్ అ ఎండోథెర్మిక్ ప్రాసెస్. సో సింపుల్గా కేసీఎల్ అనేది హీట్ని తీసుకుంటుంది, వాటర్ అనేది హీట్ని ఇస్తుంది. Heat evolved by water is also equal to heat evolved by KCl dissolution. So this value we are calculating. For how much we are calculating? For dissolution of 7.45 grams of KCl dissolution, we are calculating the heat evolved by water. And what is the formula? Ms delta T. And what is the mass of water? Here, this 25 grams of water giving heat, and also this 200 grams of water also involved. When you are dissolving KCl in water, this water and this water, both waters are involved in the heat process. That's why total mass we have to take 200 plus 25, 225. This is a mass of water, and specific heat of water in the question it is mentioned 4.2, and delta T is 3. Delta T is 3. So this value is 2835 joules. 2835 joules. That is for 7.45 grams. So when you are dissolving 7.45 grams KCl in water, the heat required for dissolution is 2835 joules. Now we have to calculate delta H per mole. Therefore, per mole 74.5. It is a molecular weight of KCl. Molecular weight of KCl for 74.5 grams of KCl. How much heat is involved? Therefore, heat is 2850. 28,350 joules per mole. 28,350 joules per mole. That means 28.35 kilojoule per mole. 28.35 kilojoule per mole. It is a D. సో ఇక్కడ మనం అర్థం చేసుకోవాల్సింది ఏంటంటే, ఎప్పుడైతే మనం కేసీఎల్ని వాటర్లో డిజాల్వ్ చేసామో, ఏ వాటర్లో డిజాల్వ్ చేసామో ఆ వాటర్ కూడా ఇన్వాల్వ్ అవుద్ది హీట్ ప్రాసెస్లో, అండ్ ఆల్సో కెలోరీమీటర్లో ఉన్న వాటర్ కూడా ఇన్వాల్వ్ అవుద్ది హీట్ ప్రాసెస్లో. సో టోటల్ హీట్ గివింగ్ బై ద వాటర్, you have to consider both waters. Reaction of ethylene to linear polythene is represented by the reaction. N moles of ethene is converted to corresponding polymer polyethene. So polyethene structure you can write CH2, 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 CH2 like that. So here CC bond, CC bond, 2 CC bonds for one monomer, 2 CC bonds for one monomer, 2 CC bonds for one monomer. So per each monomer we are having 2 CC single bonds. Per each monomer we are having 2 CC single bonds. Therefore, delta H of the reaction equal to, here they have given the bond enthalpy values. So here I am taking the bond enthalpy values, products, reactants minus products. Therefore, N into, here we are having N number, bond enthalpy of C double bond C plus total 4 CH bonds total 4 CH bonds, 4n into bond enthalpy of CH minus, and here total n number is there, and 2 CC single bonds, therefore 2n bond enthalpy of CC single bond minus total 4 hydrogens, 4n bond enthalpy of CH. ఇక్కడ మనం అర్థం చేసుకోవాల్సింది ఏంటంటే పర్ మోనోమర్ 2 CC సింగిల్ బాండ్స్ కౌంట్ అవుతాయి. 1 మోనోమర్, another monomer, another monomer. So 2 CC single bonds we have to count. So here this value, and the final answer is n into bond enthalpy of C double bond C minus 2n into bond enthalpy of C single bond C. Therefore n into bond enthalpy of C double bond C minus 2 into bond enthalpy of C single bond C. N into bond enthalpy of C double bond C 590 kilojoule per mole minus 2 into bond enthalpy of C single bond C 331 kilojoule per mole, and this value is minus 72 n kilojoule per mole. So this value for n moles of polymerization. For n moles of polymerization, minus 72 n kilojoule per mole. Kilojoule per mole for n moles of polymerization. But in the question they are asking about per mole of ethylene. Therefore for 1 mole, how much? Minus 72 kilojoule per mole. n moles ki 72 n అయితే 1 mole ki 72 kilojoule per mole. Answer A. Enthalpy of neutralization of H3PO3. H3PO3 is dibasic acid. H3PO3 is dibasic acid. By NaOH, it releases minus 106.68 kilojoule per mole. So when it is reacted, 2 moles reacted because 2 acidic protons are there, and the corresponding salt will be formed. And by releasing 106.68 kilojoule per mole energy. If the enthalpy of neutralization of strong acid plus strong base, it produces NaCl plus H2O by releasing 55.84 kilojoule per mole. Now what is the delta H ionization of H3PO3 into its ions? We know that 1 H plus 1 OH minus. It is a strong acid, it is strong base. 1 mole of H plus 1 mole of OH minus produces 1 mole of water. 1 mole of H plus 1 mole of OH minus gives 1 mole of water. So it releases minus 55.84 kilojoule per mole energy. Suppose 2 moles of H plus and 2 moles of OH minus is involved to produce 2 moles of water. So the energy should be minus 2 into 55.84 kilojoule per mole. So 1 mole ki 55.84 అయితే 2 moles ki మనకి రిలీజ్ అవ్వాల్సింది ఎంత? Okay, so this should be released. But for H3PO3, the amount released is only 106.68. So the value is minus 111.68 kilojoule per mole. So for 2 moles of proton, 2 moles of OH minus, the energy should be minus 111.68. But here we are getting only 106.68. So the difference is 5 kilojoules. The difference is 5 kilojoule per mole. సో మనకి రిలీజ్ అవ్వాల్సింది ఇంత, రిలీజ్ అయింది ఇంత. అంటే రిమైనింగ్ ఎనర్జీ ఎక్కడికి వెళ్ళింది అంటే ఆ రిమైనింగ్ ఎనర్జీని ఈ H3PO3 వీక్ యాసిడ్ కాబట్టి ఈ వీక్ యాసిడ్ని అయోనైజ్ చేయడం కోసం ఈ ఎనర్జీ యూజ్ అయింది. మనకు రిలీజ్ అవ్వాల్సింది -111, బట్ రిలీజ్ అయింది 106. సో రిమైనింగ్ ఎనర్జీ మనకి ఎక్కడికి వెళ్ళిపోయింది? ఈ వీక్ యాసిడ్ని అయనైజ్ చేయడం కోసం యూజ్ అయింది. సో దిస్ ఇస్ ద కరస్పాండింగ్, దిస్ వాల్యూ ఈజ్ కరస్పాండింగ్ డెల్టా హెచ్ అయనైజేషన్ ఆఫ్ H3PO3. Delta H ionization of H3PO3. Okay. If the radius of first orbit of hydrogen atom is x angstroms, then radius of the second orbit of Li+2 is. These two are single electron species. Therefore, according to Bohr's theory, radius of nth orbit equal to 0.529 into n square by z. So whenever this kind of question is given, first orbit is x angstroms and this value you should take it as unknown. Therefore, for example, this value is this constant I am taking a. Therefore, for hydrogen, radius of first orbit equal to x equal to 0.529. That value we should take it as a into first orbit 1 square upon atomic number 1. Therefore, x equal to a. And for Li+2, radius of second orbit equal to a into n value 2 square upon z value 3. Therefore, a into 4 by 3, 4a by 3, a is equal to x, therefore 4x by 3. So that's why we should take it this value as unknown, because if you have to express the value in terms of x. Therefore, the answer is Bombay. The mass of a particle is 10 power 10 grams, very small, and the diameter is 10 power minus 4 centimeter. If the speed is 10 power minus 6 centimeter per second with 0.0001% uncertainty in measurement, minimum uncertainty in its position is. When you are talking about the uncertainty, so this is Heisenberg uncertainty principle. So according to Heisenberg uncertainty principle, delta x into delta p, change in position into change in momentum, uncertainty in position into uncertainty in momentum, greater than or equal to h by 4 pi. And this one can be written as delta x into m into delta v, greater than or equal to h by 4 pi, because momentum is equal to mass into velocity. సో ఇక్కడ వెలాసిటీ అనేది మనకి చేంజ్ అవుతుంది, మాస్ ఆఫ్ పార్టికల్ చేంజ్ కాదు. సో మాస్ ఆఫ్ పార్టికల్ ఇచ్చారు అండ్ డెల్టా వి వాల్యూ ఇచ్చారు అండ్ హెచ్ వాల్యూ తెలుసు, 4 వాల్యూ తెలుసు, పై వాల్యూ తెలుసు. దేర్ఫోర్ చేంజ్ ఇన్ పొజిషన్, అన్సర్టనిటీ ఇన్ ద పొజిషన్ greater than or equal to h by 4 pi delta v. And the total diameter is 10 power minus 4 centimeter. So particle diameter not necessary for us, because in the formula we are having only delta v value and mass value and uncertainty in the position. Therefore, uncertainty in the position greater than or equal to h value 6.625 into 10 power minus 34 joules per second upon 4 into pi value 22.7 into uncertainty in the velocity. So total velocity is 10 power 8 meter per second into uncertainty 0.001 by 100. So this is a uncertainty in the velocity. Total velocity v and uncertainty is 0.01% into mass of particle 10 power. So here it is given 10 power minus 10 grams and we have to take 10 power minus 10 kg. So here we should careful about the units, meter per second and kg and joule per second. Therefore, corresponding delta X value we will get in terms of 5.28 into 10 power minus 8 meters. So that is the uncertainty in a position. So this is a Heisenberg uncertainty principle. So what is the Heisenberg uncertainty principle? Suppose if electron is revolving around the orbit, if you want to see the electron, you will focus the light. When you are focusing the light, it will take energy, it will change the position. Suppose if you are focusing light here, again electron changing position, again electron. So that means you cannot find exact position. You cannot find exact position and momentum at a time. ఎట్ ఏ టైంలో మనం ఆ స్మాల్ పార్టికల్స్కి, వెరీ స్మాల్ పార్టికల్స్కి ఎనర్జీ సప్లై చేస్తున్నాం కాబట్టి పొజిషన్ మార్చుకుంటాయి. సో ఎట్ ఏ టైం మనం పొజిషన్ అండ్ మొమెంటం ఫైండ్ అవుట్ చేయలేం. దట్ ఈస్ అ హైజెన్బర్గ్ అన్సర్టెనిటీ ప్రిన్సిపల్. ద సర్కంఫరెన్స్ ఆఫ్ థర్డ్ ఆర్బిట్ ఆఫ్ హీలియం ప్లస్ ఈస్ x meters. So for helium plus, it is also single electron species. Here 2 protons and here 1 electron. And the third orbit, this circumference is, total circumference is 2 pi r of third orbit, which is equal to x meters. Now we have to calculate the de Broglie wavelength of the electron revolving in this third orbit. Suppose same electron is revolving in the third orbit, so it revolve like this because it is a third orbit. That means it is equal to 3 lambda, because we know that it is lambda, it is another lambda and lambda. So 3 waves manaki. So we know that according to de Broglie, 2 pi r is equal to n lambda. The circumference of the orbit equal to integral multiple of wavelength. First orbit lo 1 wave, second orbit lo 2 waves, third orbit lo 3 waves. And this 2 pi r is equal to right now x meters, and third orbit 3 lambda. Therefore lambda is equal to x by 3. అంటే మనం సింపుల్గా ఇది ల్యాండా వాల్యూ, ఇది ల్యాండా వాల్యూ, ఇది ల్యాండా వాల్యూ. సో 3 వేవ్స్కి మనం ల్యాండా వాల్యూ తీసుకోవాలి. టోటల్ లెంత్ మనకి ఎక్స్ కాబట్టి టోటల్ లెంత్ అనేది ఎక్స్కి ఈక్వల్. సో మనకి 3 వేవ్స్ ఉన్నాయి కాబట్టి బై 3 చేసాం. అలా కూడా అర్థం చేసుకోవచ్చు. de Broglie సింప్లీ 2 pi r is equal to n lambda. At total pressure of P1 atm, P2 atm, N2O4 dissociated to an extent of 33.33% and 50%. The ratio of total pressures P1 and P2 is, so N2O4 dissociating to 2NO2, 1 0 1 minus alpha 2 alpha. Therefore corresponding Kp is equal to pressure of NO2 to the power 2, pressure of N2O4 to the power 1. Pressure of NO2, mole fraction of NO2 to the power 2 into total pressure to the power 2 upon mole fraction of N2O4 into total pressure to the power 1. So total pressure cancel here. Finally mole fraction of NO2 to the power 2 into total pressure upon mole fraction of N2O4 to the power 1 into no total pressure here. So this is the equilibrium constant. So here when the pressure is, total pressure is P1 atm, it is 33.33% dissociated. When the pressure is P2, 50% dissociated. Therefore, but in both cases we know that Kp value is same. Therefore here mole fraction of NO2 means 1 minus alpha by total moles, 1 minus alpha plus 2 alpha, 1 plus alpha whole square, mole fraction of NO2. So mole fraction of NO2 2 alpha by 1 plus alpha whole square into total pressure upon 1 minus alpha by 1 plus alpha. And this value finally 4 alpha square by 1 minus alpha square into total pressure. So Kp is equal to, when pressure is P1 atm, 4 into 33.33% means 1 by 3 whole square into total pressure P1 upon 1 minus 1 by 3 whole square. And again P2 condition, 4 into 50%, that means 1 by 2 whole square upon 1 minus 1 by 2 whole square, and the pressure is 1 minus 1 by 2. Here also 1 minus 1 by 2 whole square into total pressure is P2. So P1 condition lo equilibrium constant, P2 condition lo equilibrium constant, both are same. By taking the ratio, we get the corresponding value P1 upon P2, and the value is 8 by 3. సో మనకి క్వశ్చన్లో తెలియాల్సింది ఒక్కటే పాయింట్ ఏంటంటే, మనం ప్రెషర్ మార్చినంత మాత్రాన ఈక్విలిబ్రియం కాన్స్టెంట్ అనేది చేంజ్ కాదు. సో ఇన్ బోత్ కేసెస్ వీ హ్యావ్ టు మేక్ ద ఈక్వల్ ఆఫ్ కరస్పాండింగ్ కేపీ వాల్యూ. First Kp value and second condition Kp value, both Kp values are same. By equating these two, we get the ratio. N-coproic acid found in coconut and palm oil is used in artificial flavors, and it has a solubility in water equal to 11.6 grams per liter. Saturated solution has pH value 3. Ka of acid we have to find out. So it is simply monoprotic acid, C5H11COOH. It is a weak acid, C5H11COO minus plus H plus. Concentration C 0 0, C minus C alpha, C alpha, C alpha. Therefore Ka is equal to C alpha into C alpha by C minus C alpha. That means you can write simply C alpha square by 1 minus alpha. And H plus concentration equal to C alpha, and which is equal to root over C Ka. Suppose if I take 1 minus alpha approximately equal to 1, it is a equation. So here this is a derivation generally. So derivation అంతా జస్ట్ మనకి ఒకసారి మనం డెరివేషన్ ఎలా చేయాలో రివైజ్ చేసుకుంటారని రాశాను. మనకి సింపుల్గా మోనోప్రోటిక్ యాసిడ్కి 1 మైనస్ ఆల్ఫా ఈక్వల్ టు 1 తీసుకుంటే ఈ ఫార్మ్లో డైరెక్ట్ యూజ్ చేయొచ్చు. సో pH వాల్యూ 3 కాబట్టి H ప్లస్ ఈక్వల్ టు 10 పవర్ మైనస్ 3 ఈక్వల్ టు రూట్ ఓవర్ C ఇంటూ Ka. Therefore CKa is equal to 10 power minus 6. Now we have to calculate the C value. That is concentration. So what is the concentration of this acid, which is equal to number of moles into 1000 by volume. Now here the solubility they have given 11.6 grams per liter. That means this is equal to weight 11.6, molecular weight 116 into 1000 by volume per liter. Per liter the solubility is 11.6 grams. Therefore here we have to take the per liter, and this concentration is equal to 10 power minus 1. Therefore C value is 10 power minus 1. So 10 power minus 1 into Ka is equal to 10 power minus 6. Ka is equal to 10 power minus 5. Answer B. It's a very simple question. So ఇదంతా రాసిన తర్వాత నాకు లెందీ అనిపిస్తుంది మీకు, బట్ క్వశ్చన్లో నాకు జస్ట్ కాన్సన్ట్రేషన్ ఫైండ్ అవుట్ చేసి ఈ H ప్లస్ ఫార్ములా తెలిస్తే మనకు ఆన్సర్ వచ్చినట్టే. A solution has initially 0.1 molar formic acid, 0.2 molar HCl. Formic acid and HCl. Ka of formic acid 2.56 into 10 power minus 5. So it is a weak acid, H plus and HCO minus, and corresponding Ka value 2.56 into 10 power minus 5. Ka of HCN. So it is also weak acid, Cn minus plus H plus. Therefore, Ka is equal to 9.6 into 10 power minus 10. సో ఇక్కడ మనం ఒకటి అబ్జర్వ్ చేస్తే ఇక్కడ కేఏ వాల్యూ 10 పవర్ మైనస్ 5 ఉంటే ఇక్కడ కేఏ వాల్యూ 10 పవర్ మైనస్ 10 ఉంది. సో ఈ డిఫరెన్స్ అనేది చాలా ఎక్కువగా ఉంది యాక్చువల్గా. సో దట్ మీన్స్ ఇన్ ద ప్రెజెన్స్ ఆఫ్ ఫార్మిక్ యాసిడ్, సో HN is very weak acid. Relatively it is weak acid and it is a strong acid relatively. Now we have to find out the incorrect statement. We have to find out H plus concentration, HCO minus concentration, Cn minus concentration, POH value. Now here, without solving the question, without solving numerical, we can solve the question. How? POH is 2.8. That means pH equal to, so 14 minus 2.8, that is 11.2. 11.2. So pH is 11.2, not at all possible. Why not at all possible? Here we are having mixture of weak acids. So mixture of weak acids always pH value less than 7. Mixture of weak acids pH value always less than 7. So the option D is incorrect. So directly without any calculation, if you observe this point immediately, you can mark the answer. Now how to solve the question? It is a formic acid, concentration is 0.1 and it is 0.2. So 0.1 minus x, 0.2 minus y. Since we are having mixture of solutions x plus y and x plus y, therefore Ka is equal to x into x plus y upon 0.1 minus x, and this is equal to y into x plus y upon 0.2 minus 5. So it is the first equation and it is the second equation. So on solving these two, we get x and y values. So H plus concentration means x plus y, Cn minus concentration means y value, and HCO minus value is x value. So two equations, two unknown terms. On solving these two, we get x and y values. Liquids A and B form ideal solution. So we are having ideal solutions A and B, A liquid and B liquid. A certain solution of A and B contains 25 mole % of A, whereas the vapor in the equilibrium with the solution at 298 Kelvin 50% of A, and we have to calculate the ratio of vapor pressures of pure A to pure B. సో ఈ క్వశ్చన్ చూడగా మనకు అర్థం కావాల్సింది క్వశ్చన్ రిలేటెడ్ టు లిక్విడ్ సొల్యూషన్స్. సో ఇక్కడ మనకి లిక్విడ్ ఫేజ్ ఉంటుంది, ఇక్కడ మనకి వేపర్ ఫేజ్ ఉంటుంది. సో మనకు అనుకోవాల్సింది సింపుల్గా P0 ఆఫ్ A అపాన్ P0 ఆఫ్ B. సో మనకి ఇచ్చిన ఇన్ఫర్మేషన్ లిక్విడ్ ఫేజ్లో మోల్ ఫ్రాక్షన్ ఆఫ్ A 0.25, వేపర్ ఫేజ్లో and corresponding mole fraction YA is equal to 0.5. జనరల్గా లిక్విడ్ ఫేజ్ X అని తీసుకుంటాం, వేపర్ ఫేజ్ Y అని తీసుకుంటాం. సో ఇది వాడిచ్చిన ఇన్ఫర్మేషన్. మనకు కనుక్కోవాల్సిన P0 ఆఫ్ A బై P0 ఆఫ్ B. సో మనకి ఇక్కడ తెలియాల్సిన ఈక్వేషన్ ఏంటంటే ఇన్ టర్మ్స్ ఆఫ్ liquid mole fraction, pressure of A is equal to mole fraction of A in the liquid phase total P0 of A according to Raoult's law, and according to Dalton's law mole fraction of A in the vapor phase into total pressure. This is according to Raoult's law, it is according to Dalton's law. Similarly, pressure of B is equal to mole fraction of B in the liquid phase into P naught of B equal to, according to Dalton's law, mole fraction of B into total pressure. So now we have to calculate the ratio. Which ratio? P naught of A upon P naught of B. Therefore, we will take the ratio XA P naught of A upon XB P naught of B equal to YA total pressure upon YB total pressure. Total pressure will be cancelled. Therefore, P naught of A upon P naught of B equal to mole fraction of A vapor phase, mole fraction of B vapor phase, mole fraction of B liquid phase, mole fraction of A liquid phase. And this is 1 by 2 upon 1 by 2, because we know this value is 0.5, and mole fraction of B 3 by 4 and 1 by 4. Therefore, the ratio is 3 by 4. Sorry, 1 by 2, 1 by 2 cancel. The ratio is 4, 4 cancel, 3:1, 3 by 1. Therefore, answer is 3:1. సో ఇప్పుడు మనం డాల్టన్స్ లాని రౌల్స్ లాని మనం రెండు అర్థం చేసుకుంటే క్వశ్చన్ చేసుకోవచ్చు. A solution having 54 grams of glucose per liter, osmotic pressure 4.56. So for glucose, pi value is 4.56 and concentration C is equal to 54 grams per liter. If the osmotic pressure of urea, so we are taking the urea. For urea, osmotic pressure is 1.52 bar, and at the same temperature, then what would be its concentration? So we have to calculate the concentration. So in this case, osmotic pressure formula pi is equal to CRT. In this case, osmotic pressure formula pi is equal to CRT. Therefore, pi of glucose 4.56, concentration 54 by molecular weight of glucose 180 into RT, and here pi value is 1.52 equal to, we have to find out concentrations. Therefore, C into R into T. So by taking the ratio, by taking the ratio of these two values, we get the concentration, and the concentration is 0.1 molar. Answer A. For the reaction H2 plus 2AgCl, H2 1 bar plus 2AgCl gives 2Ag plus 2H plus. So it is 1 bar and it is 0.1 molar plus 2Cl minus 0.1 molar. H plus concentration 0.1 molar, Cl minus concentration 0.1 molar. Now what they have given? They have given delta G naught value minus 48,240 joules at 25 degrees Celsius. Now we have to calculate the E value. So E is equal to E naught minus 0.059 by N log Q, and E is equal to E naught minus 0.059. So ఇక్కడ 2H plus H2 converting to 2H plus 2Ag plus converting to 2Ag. That means 2 electrons transferring both in oxidation and reduction. Therefore, N value is 2 log of H plus concentration whole square Cl minus concentration whole square upon pressure of H2 to the power 1. So AgCl అనేది సాలిడ్, సిల్వర్ అనేది సాలిడ్. సాలిడ్ నెగ్లెక్ట్ చేసి మనం కరస్పాండింగ్ కాన్సన్ట్రేషన్స్ అండ్ ప్రెషర్ తీసుకోవాలి. సో ఇప్పుడు మనం ఏం ఫైండ్ అవుట్ చేయాలి? ఈ వాల్యూ ఫైండ్ అవుట్ చేయాలి. ఈ నాట్ వాల్యూ డెల్టా జీ నాట్ వాల్యూ ఇచ్చాడు. సో డెల్టా జీ నాట్ ఈజ్ ఈక్వల్ టు minus NFE naught. Therefore, minus 2 into 96,500 coulombs and E value in terms of volt, which is equal to minus 48,250 joules. Joules and coulomb volt. So coulomb volt cancel అవుతుంది. And finally we get corresponding E value. So E is equal to 0.25. Sorry, E naught value. E naught value is 0.25. So E naught value, we know the E naught value, H plus concentration 0.1 molar, Cl minus concentration 0.1 molar, pressure of H2 1 atm. Therefore, we get corresponding E value. So E value is 0.368, which is 0.37 volt. Answer B. So this చాలా సింపుల్ క్వశ్చన్. నెక్స్ట్ ఈక్వేషన్ రాసుకొని మనకి ఏ వాల్యూస్ కావాలి, ఏ వాల్యూస్ క్వశ్చన్లో ఇచ్చాడని చూసుకుంటే ఆన్సర్ వచ్చేస్తుంది. The equivalent conductance at infinite dilution NH4Cl, NaOH, NaCl. So lambda naught of NH4Cl 129.8 corresponding units. Lambda naught of NaOH 217.4. Lambda naught of NaCl 108.9. Ohm inverse centimeter square per mole. So units are similar. Now what they have given, if the equivalent conductance of 0.01 normality NH4OH is given, therefore lambda of NH4OH equal to 9.532 ohm inverse centimeter square mole inverse. We have to calculate the degree of dissociation. We know the formula, degree of dissociation equal to lambda by lambda naught. So this one can be lambda m, this one also can be lambda n, because n factor is, we are taking the ratio, so n factor will be cancelled. So you can take lambda equivalence ratio directly. Therefore lambda naught of NH4OH equal to lambda naught of NH4Cl plus lambda naught of NaOH minus lambda naught of NaCl. ఇక్కడ Cl ఉంది, Cl క్యాన్సిల్ అయిపోతుంది, Na ప్లస్ ఉంది, Na ప్లస్ క్యాన్సిల్ అయిపోతుంది. We will get NH4 plus value and OH minus Y value. So here we know the lambda naught value, and here lambda value is given. By taking the ratio, we get the corresponding alpha value. It is a simple question, direct question. So that is 4%. The suggested mechanism for the reaction chloroform plus Cl2 gives CCl4 plus HCl. So Cl2 dissociating K1, backward reaction constant K2, 2Cl radical. It is a fast reaction. Chloroform plus Cl radical, K3 rate constant, HCl plus CCl3 slow reaction. So according to rate of reaction definition, rate of reaction depends on the slow step. Therefore rate is equal to K3 into concentration of chloroform to the power 1, concentration of Cl radical to the power 1. So whenever you are writing rate of reaction, in the rate of reaction we should have only either reactants or products. We should have only either reactants or products, but it is intermediate. So chloroform is reactant, it is okay, but it is intermediate. So we have to remove the intermediate. How to remove the intermediate? Here in the first equation they have given equilibrium constant. So from this we can write equilibrium constant, rate constant of forward upon rate constant of backward equal to Cl radical to the power 2 upon Cl2 to the power 1. From this we can write Cl radical to the power 2 is equal to K1 into K2 Cl2 to the power 1. Therefore R is equal to K3 into K1 by K2 chloroform to the power 1 Cl2 to the power 1. So K1 by K2 means equilibrium constant. Therefore rate is equal to here Cl radical. We have to take Cl radical equal to K1 by K2 to the power 1 by 2 Cl2 to the power 1 by 2. Therefore here to the power 1 by 2 to the power 1 by 2. So this is our final rate law. Here chloroform is reactant, Cl2 is also reactant. So the rate expression should be in the form of either reactants or products. It should not contain any intermediate. If any intermediate is present like this, we have to remove the intermediate by using the corresponding equilibrium constant or corresponding steady state approximation. The values of enthalpies of reactants and products X and Y joules per mole. Enthalpy of reactant X, enthalpy of product Y. That means energy of reactant X, energy of product Y. If the activation energy for the backward reaction is Z, then the activation energy for the forward reaction will be. సో మనకి ఏంటంటే ఒక రియాక్షన్ తీసుకున్నప్పుడు ఈ టైప్ ఆఫ్ గ్రాఫ్ తీసుకుంటే ఇది రియాక్టెంట్ ఎనర్జీ X, ఇది ప్రొడక్ట్ ఎనర్జీ Y, ఇది యాక్టివేషన్ ఎనర్జీ ఆఫ్ this value is activation energy of forward reaction and this value is activation energy of backward reaction. Activation energy of forward reaction, activation energy of backward reaction. Okay, so we know that delta H is equal to products energy minus reactants energy. Products energy minus reactants energy equal to activation energy of forward minus activation energy of backward. Therefore Y minus X equal to activation energy of forward minus activation energy of backward Z. Therefore activation energy of forward equal to Z plus Y minus X. Therefore answer D. At 25 degrees Celsius, the solubility product of CuCl is given Ksp of CuCl equal to 2 into 10 power minus 7 and E naught of this corresponding cell is given E naught of Cl minus 2 CuCl to Cu equal to 0.128 and E naught of Cu plus 1 to Cu is given. See, they are asking. Okay, so E naught of this electrode is given, E naught of this electrode we have to find out. సో ఇక్కడ మనకి 2 types of equations అర్థం చేసుకోవాలి. ఒకటి మనకున్న బేసిక్ రియాక్షన్, ఇక్కడ ఈ రియాక్షన్ CuCl plus 1 electron gives Cu plus Cl minus corresponding E Cl minus to CuCl to Cu equal to E naught of Cl minus 2 CuCl to Cu minus 0.06 by N log of Cl minus concentration. It is one equation. And another one we have to understand Cu plus 1 electron gives Cu. Therefore E of Cu plus 2 to Cu equal to E naught of Cu plus 1 to Cu minus 0.06 by N log of 1 by Cu plus concentration. The first మనం అర్థం చేసుకోవాల్సింది ఏంటంటే ఈ 2 ఈక్వేషన్స్ కూడా సేమ్. ఈక్వేషన్ ఇలా ఎక్స్ప్రెస్ చేసినా ఈ కరస్పాండింగ్ ఈ వాల్యూ అనేది సేమ్ ఉంటుంది. ఇది ఫస్ట్ మనం అర్థం చేసుకోవాల్సింది. ఎప్పుడైతే మనం సేమ్ అనుకుంటామో అప్పుడు ఆ ఈక్వేషన్ ఎలా రాసుకోవచ్చు? E0 of Cl minus 2 CuCl plus C to Cu gives 0.06 by n log of Cl minus equal to E0 of Cu plus 2 Cu minus 0.06 by n log of 1 by Cu plus. సో ఇది ఫస్ట్ మనం సెల్ రియాక్షన్ ఇలా రాసినా ఈ కేసులో ఈ టూ వాల్యూస్ కూడా సేమ్ వస్తాయి. therefore corresponding E0 of Cl minus 2 Cl minus CuCl Cu equal to E0 of Cu plus 1 Cu minus 0.06 by n log of 1 by Cu plus 0.06 by n log of Cl minus. So this can be written as E0 of Cu plus 0.06 by n log of Cu plus concentration plus 0.06 by n log of Cl minus concentration. And this can be written as E0 of Cu plus 0.06 by n log of Cu plus concentration into Cl minus concentration. Therefore E0 of Cu plus 2 to Cu plus 0.06 by n log of Ksp. So this is a expression. సో ఒకవేళ ఈక్వేషన్ డైరెక్ట్ గుర్తుంటే క్వశ్చన్ మనం డైరెక్ట్ చేసుకోవచ్చు. సో ఇది గుర్తుపెట్టుకోవాలి కూడా, ఈ ఈక్వేషన్ డైరెక్ట్ గుర్తుపెట్టుకోవాలి కూడా. సో ఇక్కడ మనం ఒకే ఒక పాయింట్ అర్థం చేసుకోవాల్సింది, సెల్ నోటేషన్ ఇలా తీసుకున్నా ఈ వాల్యూస్ అనేవి సేమ్ ఉంటాయి. సో బోత్ ఆర్ కరెక్ట్. ఓకే, సో మనకి కరస్పాండింగ్ ఈ వాల్యూస్ ఈక్వల్ చేసుకుంటే మనకి డెరివేషన్ అనేది వస్తుంది. ఇక్కడ మనకి క్వశ్చన్లో ఈ వాల్యూ ఇచ్చాడు. ఈ వాల్యూ ఎంత ఇచ్చాడు? 0.128. ఈ వాల్యూ ఫైండ్ అవుట్ చేయాలి. అండ్ కేఎస్పి వాల్యూ ఇచ్చాడు. ఎంత ఇచ్చాడు? 2 × 10⁻⁻7. ఎన్ వాల్యూ ఎంత? 1. ఎన్ వాల్యూ 1. ఇక్కడ 1 ఎలక్ట్రాన్, ఇలా తీసుకున్నా 1 ఎలక్ట్రాన్. therefore corresponding E0 of Cu plus 2 to Cu value 1.682 volt. So try to remember this equation for KSP related questions. H2S is a toxic gas with rotten egg like smell. H2S is a toxic gas with rotten egg like smell is used for the quantitative analysis. If the solubility of H2S in water at STP is 0.2 molality is given, the Henry's law constant for H2S in water at 273 Kelvin is. So Henry's law constant we have to find out. So it is a water, and here H2S vapor is there, and some amount of H2S is dissolved, and this H2S in water molality 0.2. This H2S molality in water 0.2, and we know the Henry's law equation, P is equal to Henry's law constant into mole fraction. So pressure is STP condition, that means 1 bar or 1 atm STP condition, and KH value into mole fraction. So molality equal to number of moles into 1000 by molecular weight of solvent, that means here water, weight of solvent, not molecular weight of solvent, weight of solvent. So molality is equal to mole fraction of solute upon 1 minus mole fraction of solute into 1000 by molecular weight of solvent. Molecular weight of solvent. So here we know the molality. So molality 0.2 is equal to mole fraction of solute upon 1 minus mole fraction of solute into 1000 by molecular weight of solvent 18. From this we calculate the mole fraction of solute. From this we calculate the mole fraction of solute. So by substituting the mole fraction of solute here, we can calculate the KH value in terms of ATM. In terms of ATM. So we know that 1 ATM is equal to 101,325 pascals. Therefore corresponding KH value is 2.78 into 10 power 7 pascals. సో క్వశ్చన్ సింపుల్గా ఏంటంటే ప్రెషర్ ఇచ్చాడు, ఎస్టీపీ కండిషన్, కేహెచ్ వాల్యూ ఫైండ్ అవుట్ చేయాలి, మోల్ ఫ్రాక్షన్ తెలియదు, బట్ మొలాలిటీ ఇచ్చాడు. సో మొలాలిటీ నుంచి మోల్ ఫ్రాక్షన్ ఫైండ్ అవుట్ చేసి, సో మోల్ ఫ్రాక్షన్ ప్రెషర్ వాల్యూ సబ్స్టిట్యూట్ చేస్తే కేహెచ్ వాల్యూ వస్తుంది. ఇక్కడ మనం ప్రెషర్ అనేది ఇక్కడ ప్రెషర్ ఏటీఎంలో సబ్స్టిట్యూట్ చేస్తే ఏటీఎంలో ఆన్సర్ వస్తుంది, పాస్కల్లో సబ్స్టిట్యూట్ చేస్తే పాస్కల్లో ఆన్సర్ వస్తుంది.